Hi, we're a student from Diploma in Mathematical Sciences, and today we are going to show you about application of differentiation. This is our assignment for Calculus 1, MAT 183.
So this video will be presented by our group, Ainul Radia, Dania Eliza, Nurina Amani and Nurul Fazana.
So, what is differentiation? Differentiation is a process of finding a derivative or rate of change of a function by using three basic derivatives. There are three techniques of solving differentiation. Firstly is derivative of sums and difference. Secondly, derivative of a product function which is called the product rule. Lastly, derivative of a rational function which is called the quotient rule. When we differentiate y, it will become dy over dx. And same goes to fx. When we differentiate fx, it will become f prime x.
So, as we all know, differentiation can be applied in our daily life. There are 6 ways of how we can apply it. The first one is on Rolle's theorem. Second, mean value theorem. Next, it can also be used to solve problem of maximum and minimum value. Besides that, related rates can also be found using this differentiation. Moreover, it can analyze the first function, which is concavity, and inflection points, and also intervals of increasing and decreasing function. Last but not least, it also analyzes the second function, which is relative extreme of first and second derivative test.
Related rates. Related rates are rates of change associated with two or more related quantities that are changing over time. Agreeably, the rate of change in the volume V is related to the rate of change in the radius R. So in this case, dV over dt and dr over dt are related rates because V is related to R. And the rate of change usually with respect to time. That is why we use t, dt. So how to solve related rates problems? Firstly, we need to find equations that are related the two quantities. So in this case, dv and dr are related rates. And secondly, we can use chain rule or implicit method.
So, this is our problem statement. Here in figure 2.1, we have closed cylindrical container of radius r cm and height h cm is to be made to hold 500 cm cube of liquid with surface area A equals to 2 pi r square plus 1000 divided by r.
So, let's solve the problem.
Okay, before we start, let me explain first, step by step, what we need to do. So the first one is we need to show that the surface area of the container is A equals to 2 pi r square plus 1000 divided by r. Next, we need to find the volume of R and H that minimize the total surface of the container. And the last one is we need to find the minimum surface area of the container.
We need to show the surface area of the container is A equal to 2 pi r squared plus 1000 over r. How do we show that? So firstly, we need to know that the formula for a cylindrical volume is V equal to pi r squared h. And the formula for surface area is A equal to 2 pi r squared plus 2 pi r h. And as we know, a container can hold up to 500 centimeter cubed. Therefore, here, V will equal to 500 centimeter cubed. And hence, we know that V are also equal to pi r squared h. So basically, it is also equal to 500 centimeter cubed. From this equation, we can get the value of h. So we can do a simple calculation, as here we can get h will be equal to 500 over pi r squared. Here, let h equal to 500 over pi r squared inside surface area formula. As we know, surface area formula, A equal to 2 pi r squared plus 2 pi r h. We can substitute h with 500 over pi r squared. So the new formula, the new equation will be surface area equal to 2 pi r squared plus 2 pi r in bracket 500 over pi r squared. After that, we can eliminate pi and r. The next equation, we can get 2 pi r squared plus 2 in bracket 500 over r. And here, we can multiply 2 and 500, so we show that surface area are equal to 2 pi r squared plus 1000 over r.
The second question is finding the value of radius and height that minimize the total surface of the container. By using the first derivative test, dA over dr equal to 0. So, surface area equal to 2 pi r squared plus 1000 over r. We differentiate the surface area and it will become dA over dr equal to 4 pi r minus 1000 r to the power of negative 2. As written above, dA over dr equal to 0. So we substitute 0 in the equation. And it will become 0 equal to 4 pi r minus 1000 r to the power of negative 2. We bring the negative to the right side and it will become positive. So the next step is it will become 4 pi r cubed equal to 1000 r. We leave the left side as r cubed and we bring the 4 pi to the right side and it will become r cubed equal to 1000 r over 4 pi. So we just put the cube root, and 79.577 is from the 1000 pi, and we will get the radius of 4.301 centimeter. So to find the height is the formula is 5000 over pi r. So we just substitute the r that we get just now into the formula, and we will get the height of the container is 8.604 centimeter.
So, the last question is we need to find the minimum surface area of the container. Okay, to answer this question, we need to use second derivative of functions. So, we have d square a divided by dr square equals to 4 pi plus 2000 divided by r power of 3. After that, we need to substitute r with 4.30 in the equation. So, it will be 4 pi plus 2000 divided by 4.30 power of 2. And we get the answer is positive. Based on the theorem, if f2 prime x is more than 0, then the function is minimum value. So here, r is considered as minimum value. So to know the minimum surface area of the container, we can substitute r in the main function, which is 2 pi r squared plus 1000 divided by r. After we substitute, it will be 2 pi multiplied by 4.30 power of 2 plus 1000 divided by 4.30. And after we calculate, we get 139.43 centimeters square, and this will be the final answer of the questions.
In conclusion, by applying differentiation method into this problem, we can conclude that the application of differentiation can be used to define a value of volume, to solve any other kind of problems, and to solve problems related to value of a volume. Before we ended our video, we are really grateful because we managed to complete this video presentation within the time given by our lecturer, Madam Susanawati. This assignment is impossible to be done without the amazing cooperation and effort from our group members, me, Dania, Amani, and Farzana. We also sincerely thanks to our lecturer of Calculus 1, Madam Susanawati, for the guidance and willingness to help us in what we are lacking when completing this assignment, and surely for teaching us this course. Last but not least, we would like to express our gratitude to our classmates who keep on encouraging us all this time. Thank you!